How can an object have zero velocity and still be accelerating? This question is posed in the forum, and I expect we'll get a variety of good answers. My answer is based on the definitions of velocity and acceleration. In order to describe the movement of an object, we need to specify its position, velocity, and acceleration. Velocity and acceleration are both rates. Velocity is the rate at which position changes with time. Acceleration is the rate at which velocity changes with time. Here's an example from your book. A car starts at rest, and 5 seconds later, it's traveling with a velocity of 20 meters per second. Its acceleration is 4 meters per second, meaning that the velocity increases by 4 meters per second for every second that it travels. The acceleration is also written as 4 meters per second squared. So with our acceleration of 4 meters per second squared, if we assume that at t equals 0, the car is at rest, then at t equals 1 second, the car is traveling with a velocity of 4 meters per second. We're interested in the point when the velocity was equal to 0, so let's work backward in time. At t equals 1/10 of a second, the velocity was 0.4 meters per second. At t equals 1/100th of a second, 0.01 seconds, the velocity was 0.04 meters per second, or 4 centimeters per second. You can imagine looking at smaller and smaller time intervals. So at t equals 1 millisecond, the velocity was 0.004 meters per second, or 4 millimeters per second. The point is that even when the velocity is equal to 0, it's still changing. If the acceleration is constant, then the velocity is changing at a constant rate. When the velocity is small, the position is not changing very quickly. But the rate at which the velocity is changing is given as the constant acceleration.